Okay, it's 8 a.m. sharp my time. I think it's 1 p.m. Vienna time. Nick and Loa, uh, should we get started? Are you trying to say something, Loa?
No, I let do it.
Okay, I think we have a tight agenda, so we'll get going. Welcome to the IETF 113 MPLS working group session. This is a hybrid online with physical presence. Not so much of a physical presence there, as was pointed. Um, uh, my name is Tarek, and the other working group chairs, co-chairs that we have are Loa and Nick. Our secretary is Mac. He's going to be helping us on minute taking today. I see him in the queue. Um, I want to welcome our new AD, Andrew Elston. It's my pleasure and our pleasure to work with you. Hello, and looking forward to working with you. Um, so let me proceed to the next slide then. This is our usual Note 12. It governs the intellectual property at IETF as well as the code of conduct. If you're participating in this conference and you're abiding by these rules, so make sure you read them and understand them. Uh, we're leaving some pointers here that might be helpful for the working group. Notably, we have a pointer to the working group wiki, where we can get to the design team wiki pages as well as other material. The slides are there on the materials page. And we are also leaving the GitHub link where we're having some work in progress drafts that the design team as well as the working group in general can leverage and use. So this is our agenda for today. It is pretty packed. Um, uh, the status slides are, we have almost 11 or 12 slides that we compiled, but I will not go through all of them in the interest of time. And it is the right time if anyone wants to bash this agenda, change anything or add or remove, please sound your opinion. I do see Zafar is in the queue. So I will stop right here and allow you to go and ask. Go ahead.
Yeah, so many thanks. There is a slot for policy or NPLS resolve label to use. I could not find a working group document. Oh, sorry, not working group. Any document associated with this. All I see is some slides that are non-technical and full of FUD and attacks. So I just wonder about that being selected as the agenda item.
And we do have a slot for work that was presented at the design team. It's coming up on the next slide. Um, it's a policy on special purpose label reuse. The design team had worked on it, and Tony had given a presentation talk on it. And we thought it would be useful for the working group this time to listen to the talk in general rather than just the design team. Um, uh,
Okay.
that's
Okay.
that's
Thanks.
yeah.
Thanks.
Okay. Thanks, Zafar. Uh, I will proceed unless anyone else. I think Loa is there in the queue as well. Do you want to add anything?
Yeah, I just wanted to tell Safar, but one of my questions to Tony would be if he thinks this is worth writing up as a draft. So uh, look at this as early work.
I would be happy to write it up as a draft if people feel it's really necessary. If people think it's contentious, yes. If people will simply accept it and go with it, then why bother?
I'm not suggesting that you write a draft.
Thank you.
Okay, thank you. I'll move on, and next we have an errata that was reported since last time we met. It's against RFC 6512. From the looks of it, there is a editorial maybe or a typo. Inter AS, it should be intra AS, but it might have a technical meaning associated with it. We will have to sync up with AD on this and see how we'll need to verify that or pursue that further. On the next slide, we since last time we have had a new RFC. We want to thank the authors, the Shepherd, as well as the working group on working on and producing this document. We do have two other documents that are in the RFC editor queue. One is in its the final stages in the auth 48, as the second one is in misref, waiting on another document. The other document is also by the same authors, and I think Loa is the shepherd. Do you want to comment on what's holding up the other document, Loa?
I don't really want to, but the truth is that that's me. I've been too busy. I will take care of it after the meeting.
Okay, thanks. We do have a new document that was adopted since last time we met. And I don't want to, we do have a set of documents that were updated, and like I promised, I will not go through the full status report. I will leave it for the working group to inspect the slides if they're interested. So I will switch to the next item on the agenda unless anyone has any specific question. Rakesh, I see you in the queue, so feel free to go ahead.
Yeah, I have a very quick comment on that draft IETF MPLS-6374-SR. So we have requested the working group last call on it. I'm not sure if you track it separately or not, but just a note. Thanks.
Thanks for the reminder. We do have a list of documents that have requested the adoption. Yeah. Okay. I'll change the deck to the first presenter, who is going to be Rakesh, I believe. Yes, it is Rakesh. Okay. I will give you the control on the slides, Rakesh, as well. You should be able to flip through them from the bottom of the screen.
Yeah, I see it. Thanks, Tarek. Hi, everyone. Good morning. My name is Rakesh Gandhi. I'm presenting the MPLS data plane IOM draft on behalf of the co-authors listed here. So the agenda is requirements and scope of the draft, the summary of the protocol, and discussions next steps. So this is the draft is about carrying IOM data fields with MPLS encapsulation. So there is work going on in IPPM working group. There are a couple of drafts on the IOM data. I believe they have finished working group last call as well. This is for edge to edge as well as hop by hop IOM. So just a brief history of this draft. It's been around for more than 3 years now. It used to be in spring. It was presented there, then moved to MPLS working group because it's a generic application to MPLS data plane. Last year we did MPLS RT expert review, and there were good suggestions came out. One of them being use a GACH for the IOM. So we have included that suggestion. Draft was renamed to focus on MPLS, all MPLS data plane. There were some concerns raised with requesting of the multiple ESPLs and impact on MSD. That might be the reason why we trigger the DT design team as well, based on some review comments. So we have updated the draft to address those comments as well. Draft was presented a couple of times, and just so we'll focus on the changes and not go through in a lot of details this time. So this is the IOM GACH type we defined to carry the IOM data fields. This was based on the MPLS RT expert review feedback that this is a good option for it. So we have added that in the draft. There are two indicators used to be different as ESPL labels, but based on feedback, one option is to define the two flags. One indicates that there is IOM data present after the bottom of the stack, and there's a second flag that says it needs the hop-by-hop processing. So the label can be entropy label, it can be SPL or network programming label. This is something we can discuss as part of the working group process. So yeah, we talked about the option types. So if it's end-to-end, IOM defines the option types for end-to-end. It's actually called edge-to-edge processing and then hop-by-hop processing. So the packet will look like this with IOI indicator that says that there is an IOM data after the bottom of the stack, and as we had defined GACH for it. So this is based on discussion so far. Packet would look like this. The procedure is simple. I will not go into the details of the procedure, but Encap node will add it, and IOM as well as the indicator midpoint will ignore it, and decap node will process the IOM and remove the MPLS header with IOM. For hop by hop, there is another flag defined. This says that IOM needs the hop by hop processing. Procedure is very similar to edge case, except now you have a hop by hop processing required flag set, and midpoint or intermediate node will process the IOM data based on the flag. So welcome your review comments and suggestions on this important work, and many thanks for all of the review and comments, including MPLS RT expert review. We are requesting working group adoption, and whatever the open items, we can take it up as part of the working group process. That's all I had. Thank you.
Thank you. Go ahead, please, with your question, Greg.
Yes, Rakesh, thank you for presentation. As you mentioned, so their IOM encapsulation in MPLS is one of their cases for MIAD, and it's reflected in the draft. So can you clarify what type of encapsulation this draft proposes?
Yeah, so this was, there is a GACH type defined based on MPLS RT feedback to carry the IOM data field. And then there is a second indicator that's defined as bits in the TTL field of a label. Label being entropy label or SPL or network programming label to be discussed as part of the working group process.
So you're proposing multiple solutions?
No, there is indicator and then there is data. right? This is in line with two things that's also part of the MIAD.
But my understanding is that GACH is not part of the MIAT or not part of their direction that Open Design Team is working on.
Yeah, so this is based on the MPLS RT experts' suggestions to use GACH and incorporate it in the draft. If MIAD comes up with a different header, then it can be adapted as part of the working group process.
Okay, let's take it to the list. Thank you.
Thanks, Greg.
Okay, I have a question, Rakesh. You say that the IOEM header metadata or this extension header that you're proposing should be inserted by the ingress node or any node?
So we call it the Encap node that adds the IOM Encap. We'll add as part of the Encap.
Okay. And how do you handle the case that an IOM header already exists in the packet, and someone tries to add another IOM header? So this could be an LSP hierarchy case or something like that.
Yeah, I think there is a small section in the draft that talks about it. Basically, as part of the new Encap, there are two ways of doing it: either adding a new header in the whole IOM, or appending the data to the existing IOM. So these are two options. We can elaborate and agree on which one is the right one.
Okay, I'm just concerned about the when the one egress LSR of one LSP tries to remove the whole thing, the whole header, and you want part of it to persist. And maybe I should read that section. Thank you.
Yeah, it's a good comment, Tarek. We can elaborate. Thanks.
Okay, we will move to the next presentation. Let me see if I can find it then. Interesting. I'm finding it, it's not allowing me to share.
Tarek, would you help
Yep.
me to share the slides?
Yeah, I'm. It's not letting me share your slides, so not sure. It's telling me okay. Now it is.
Yeah, I
don't know
just
what-
released Tarek. I was share slide more, so I just released it, and maybe that was the reason.
Oh, that was it then. Thank you,
Yeah.
Rakesh. Okay, let me find the.
Yeah.
Okay, is it Xiao?
Yes, I'm Xiaoming.
Okay, go ahead.
Okay. Hello, everyone. I'm Xiaoming, presenting LSP pin for SR pass seats. This draft was presented at IETF 109. This is the second time it's presented. Next slide, please.
Able to control the slides from the bottom.
Okay, I see. There's a bit delay. Okay.
Slide.
Path segment with MPLS data plane is defined in draft Spring MPLS path segment, which has passed the working group last call in Spring working group. Path segment is normally used by the egress nodes for path identification. A path segment must be inserted at the ingress node and must not be popped off until it reach the egress node. Path segment must immediately follow the routing segment pointing to the egress node. This draft provides three target fact sub-TOVs for path segment. When path segment is used to identify an SR policy, the target fact SR policy's path seed sub-TOV is included in the SP ping message. When path segment is used to identify an SR policy's candidate path, the target fact SR candidate path seed sub-TOV is included in the SP ping message. When path segment is used to identify a segment list, the target fact SR segment list path seed sub-TOV is included in the SPP ping message. This slide illustrates the format of SR policy path seed sub-TOV. As specified in segment routing policy draft, an SR policy must be identified through the tuple, head end, color, and endpoint. So this sub-TOV has three fields, head end, color, and endpoint that identify an SR policy. The egress node would use the three fields and the received path segment to validate the control plane to forwarding plane synchronization for this path segment. This slide illustrates the format of SR candidate path seed sub-TOV. As specified in segment routing policy draft, an SR candidate path must be identified through the tuple, head end, color, endpoint, protocol origin, originator, and discriminator. So this sub-TOV has 6 fields of the tuple that identify an SR candidate path. The egress node would use the 6 fields and receive the path segment to validate the control plane to forwarding plane synchronization for this path segment. This slide illustrates the format of SR segment list path seed sub-TOV. SR segment list can be identified through the tuple, head end, color, endpoint, protocol origin, originator, discriminator, and segment list ID. One more field, segment list ID, then the tuple that identifies an SR candidate path. So this sub-TOV has 7 fields of the tuple that identify an SR segment list. The egress node would use the 7 fields and receive the path segment to validate the control plane to forwarding plane synchronization for this path segment. So the authors believe this draft is straightforward and it's ready for working group adoption. Thank you.
No questions. I have a quick question for you, please. Is the path segment only relevant at the egress, or would the transit node be interested in this path segment ID?
Yes, In the 0.0 version of this draft, we have no decision on whether it's only to egress node or is also relevant to transit node. And after revision, we decided to change it to just for egress node to check, to validate. Because we think path segment, from the description of the path segment working group draft, we think it's just relevant to the egress node. That's the decision from the authors. Thank you.
Okay, thank you. We'll move to the next presenter. I guess I don't see anyone on the mic trying to ask a question. So
Okay, thank you.
Thanks. I think Kiriti is next. Let me find your set of slides deprecating.
Hello, can you hear me?
Yes. Yeah, if you come a bit closer to the mic, it was
Okay.
a little bit open. Yeah, I think I can hear you. Yeah.
All right. This is a fairly straightforward draft. Many thanks to Ron for pushing me to do this and for preparing the slides. So next slide, please. So the proposal is fairly straightforward. The LSP ping RFC 8229 basically says use a router alert option in the ping packets. And we'll explain in the next few slides why that's not a good idea and why it's unnecessary. And so we're proposing to remove this option from LSP ping. And in the process, we'll reclassify 7506 to historic. 7506 registers a routing alert option. For IPv6, you have to say why you want to use it. So it basically says we want to use it for MPLS. So we don't need it, and this is the only use of it, so it becomes historic. The reason for doing all this is that router alert does pose some security issues. So you can read RFC 6398 to understand those issues. And it also allows the 6-man effort that's looking at, how to resurrect the hop by hop options and what to do about it. They're considering whether we need router alert in IPv6, and they might get confused that LSP ping really needs it. So this gives them the freedom to say we don't need that. And the biggest thing is that we really don't need router alert in LSP ping. Next slide, please. So here's what an LSP ping packet looks like. You got to read this from the bottom up. So you got the label stack, you got an IP header inside that, and in the echo request, the router alert is mandatory. Then you have a UDP with a well-known port number saying this is LSP ping, and then you have the actual contents of the LSP ping. Next slide, please. So echo reply looks quite similar. A couple of things that are different. I don't believe you actually need an MPLS label stack. In the IP header, the router alert is optional, but then you have the UDP header, and then you have the reply contents. Next slide, please. So the motivation for putting a router alert in the echo request is essentially paranoia. We really wanted to make sure that the echo request does not go beyond the egress. So to do that, we put 3 protective mechanisms. We said that the destination address must be from 127/8 for IPv4, or this funky address for IPv6, and that's not allowed to be forwarded. So when you pull off all the labels from the label stack, you see that address, you shouldn't forward it. On top of that, we said the TTL must be set to 1. So when you do all that and you look at the TTL, you say, oh, I'm not going to forward this either. And then we said we'll put a router alert. It's like, yeah. So it's total paranoia. 2 levels are plenty. And I don't believe anyone actually implements using router alert in LSP ping. And even if they did, it's a simple change to remove it. And it doesn't add any protection. Next slide, please. For the echo reply, it's a different motivation. And this one's even more questionable. The reply has several modes. One says, I don't care about the reply. I just want to ping in the forward direction. Not used very much. The next one says reply via IPv4 or IPv6. The third, it says reply via IPv4 or IPv6 with the router alert set. And the fourth is reply via application level some control channel. So mostly what people do is 2. I don't believe anyone does 3. What 3 is about is if you just send an IP packet and you're replying to an echo request, it might get lost. And so if you use a router alert, it'll suddenly magically show up at the egress, or in this case, the ingress. I'm not sure what I was on at that moment. You'd have to ask my lawyer, my doctor, and my priest. But it's there in the RFC, and what we'd like to do is remove it. Next slide. So I think we'd like to have the working group look at this, give us feedback in terms of, especially if anyone's actually using it, if anyone actually thinks it's useful. I don't believe so, but I think the working group should review it. I think it's fairly straightforward to adopt this and actually move it on to the next stage, and to classify or reclassify 7506 as a historic. And probably it would be nice to tell I think it's 6-man that's doing the hop by hop stuff in IPv6, and tell them, hey, if you thought MPLS needed router alert, it's no longer the case. Thank you. Any questions?
Yes, we do have Greg in the queue first, in the top of the queue.
Thank you. I just want to note that through other discussions, I learned that IPv6 mapping of IPv4 loopback range has no special meaning in IPv6. And at least one operating system allows use of these addresses and they get out. So IPv6 has only one single loopback, which is address 1.
Okay, that's good to know. The reason why we actually said use the whole range was to give a little more chance for entropy, because LSP ping in the hop by hop, the trace route mode, you want to explore all the different paths. And if you're including the IP address in your exploration, in your ECMP, that would help. So that would be a little bit painful, but we still have the TTL set to 1. So thank you for pointing that out, Greg. We will look at that and come back to you, but I still think that we should remove this, but Ron and I will consult, and hopefully the working group will also give us feedback.
I agree with orthogonal, and actually it might be something that we can look at recommendation of using this range in the documents, and maybe do some bis and say, don't use this range, use just one single IPv6 address.
Oh, yeah, but then you don't get the entropy, you don't get the,
You
exploration.
can use source port number.
True. Okay. Thank you.
Loa, go
Loa?
ahead. You still have.
The question on which document you actually update. You say in the draft that you're updating 7506 and 8029. Those are fairly obvious. But in the paragraph above, you say that RC 6398 recommends to use this very carefully.
Yes.
Since you are removing the possibility to even be careful, isn't 6398 also updated?
No, 6398 says nothing about the particular use that we are talking about here. It says in general, router alert in IP packets is not a good idea, especially across the internet. So I don't believe that that's affected.
That is not the MPLS router alert. That's what you're saying.
No.
Okay. Can you clarify that?
Sure.
Okay, thanks.
Okay, thank you.
Thanks. Thank you, Kiriti. We'll move to the next presentation, and we have Tony.
Thank you.
I'll also give you the control to flip slides.
Thank you. So there are currently two proposals on the table for reusing ELI for indicating the MEAD structure. These are listed here. These are both based on draft Crane, and I wanted to talk about that a little bit. There are 6 claims of advantages for using ELI. I'm going to go through all of these in gory detail, and let's talk about and see if these claims are really true. Claim 1, we're going to get faster deployment in existing networks that already have EL already deployed with an incremental benefit. Well, what is our deployment critical path? Our working group needs to converge on what we're doing. We've got software development. We go forward, write forwarding plane and signaling code. We've got testing deployment. It's probably going to take us about 3 years to get something deployed here. The benefit of, we've agreed we're doing incremental signaling changes. So signaling is not a critical path. So claim 1 is pretty inconsequential. Whether we use ELI or different SPL is not a big deal. Claim 2, single label for entropy in the MPLS header, which helps keeping label stack size smaller. Well, any proposal that includes entropy in the MEAD extension has the same property. This is not specific to reusing ELI. This is clearly not true. Claim 3, when EL is already enabled in the network, the proposed scheme does not require hardware to support an additional SPL indicator. Well, new platforms that could have hard-coded MEAD support are years away. Having ubiquitous deployment of these is decades away. Most new platforms will have software-driven NPUs. MEAD must be supportable on legacy platforms. There's no point otherwise. So legacy platforms that will add MEAD support will not require hardware changes. That's why they're legacy. So claim 3 is kind of irrelevant. MEAD cannot wait for new hardware. Claim 4, save as a new special purpose label, and B, related protocol extensions to signal its capability in LDP, RSVP, yada, 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 etc. Okay, well, as to claim A, reusing ELI would save a SPL, but that creates risk. It's not actually backward compatible. ELI is expected to have 1 additional LSE, and adding more new LSEs for the ISD after the ELI is not going to be backward compatible. Part B, we already have agreed that we're going to be doing additional signaling extensions. So claim 4A is true, but it's more than offset by the risk, and claim 4B is inconsequential. Claim 5. An intermediate node can compute the ECMP hash with the EL field and avoid inconsistent load balancing of traffic flow that can happen when an MPLS extension header alters the label stack. Assuming MEAD includes the EL, this is always true regardless of the SPL. So this is not actually true. Claim 6. This reduces the MPLS label stack size when EL is enabled for ECMP hashing when MPLS extension header is also used. As there is only one field for EL in the MPLS header, it simplifies the MPLS header processing. Well, assuming our MEAD mechanism includes EL, this is always going to be true, regardless of SPL. So claim 6 is also false. Turning now to another option that's listed, there's a proposal that we use network group programming labels, NPL, for our SPL. We were not able to find a definition of NPL in any IETF document. I was able to find a document on the web that suggests that NPL is SR specific. And we have already agreed that MEAD is not SR specific. So this does not seem like an appropriate approach. So, all right. So basic summary, we should go ahead and use just a new SPL for MEAD. And I'll take questions.
Go ahead. Rakesh?
Yeah, hi. So thanks, Tony, for the presentation. Unfortunately, I see most of the arguments against the claims are false and not very analytical. Specifically for claim 1 about faster deployment and claim 4 about signaling extensions. If you look at the history, entropy label was developed 10 years ago, and we're still doing protocol extensions. There are new drafts in PC and whatnot. We're doing protocol extensions. So should not underestimate the amount of work required for protocol extensions for new SPL. It will take another 10 years for new SPL. If you look at the history, adding a 1-bit flag in the ELI just to say it's MEH capable is definitely a lot less work, lot less protocol work, lot less software development, easy to certify and deploy, and less impact on operators' OSS system as well. So I think it's definitely faster deployment, and it's also backwards compatible because of that bit. Encap node will not add any ELI that will expose on the legacy node. So from that point of view, it's also safe to go in brownfield network. So I think both conclusions for 1 and 4 that you have are completely false. Thank you.
Okay, I disagree with you.
Darren, you're next.
Yep. Okay, on slide 3, you note that of course, the extension header processing itself, so any MIAD, whatever that format would be done in microcode. However, I think the claim is really indicating that the existing label stack, walking, and detection of an entropy label indicator, that SPL, would remain the same. I think that's the important distinction there. So of course we're going to do whatever MIAD processing that comes after that in whatever new software implementation that would be built, but you'd still benefit from that ELI walk that you'd be doing anyway. I think most of these will probably have to take to the list, but we can continue that there, Tony. I know there's a long way.
Okay, let's take it to the list.
Thank you, Darren. Zafar, do you want to go with your question?
So my comment is regarding the claim 2, slide 5. The claim 2 is correct as 2 plus 2 equals to 4 math. Jack's presentation in PALS working group explained the point on how to reuse EL, reduces the label stack size very well. I'll reference that. In fact, is the other way around. If you add a new SPL, you add 2 additional labels. And also carrying entropy in EL as well as SPL mean you're adding 2 additional label in the stack as well. So I mean, I don't see any way you can basically support or claim that claim 2 is false.
So we already have 2 other proposals on the table where people are carrying entropy using MEAD inside of MEAD. So the
Yeah.
entropy label is not necessary whatsoever. You don't need a separate instance of the entropy label.
Like going back to what Wayne mentioned during PALS and what Rakesh mentioned, we have defined entropy label and it's not fully and correctly deployed as of today even. So assuming that you're going to migrate everything to the new SPL is just wishful thinking. So entropy label, you have to deal with it, and then you will have to deal with the 4 label pushing. So you will have to carry for some, you have to carry for entropy label, for some nodes you have to carry in the SPI is just a mess. It's 4 label. I mean, you will end up with 4 label. You are married. You are getting married with 4 label stack for a simple thing. So this is, please do not make such claims.
I disagree. The things that are on the table, if you're using MEAD, you have room to put entropy in it, and there's no point in adding an entropy label too.
And then how would you do migration? All the legacy. Anyway, we can take it offline now.
All of this is doing MEAD. Everything that assumes that we are doing MEAD already has signaling that we are only selecting MEAD capable routers.
We can take it offline today.
Okay, thank you.
Back to disagree. I beg to disagree.
Thank you, Zafar. Bruno?
Can you go back to, go forward to slide 18, please?
Slide 18.
Yes, last one.
Okay, you're well into my backup slides. Yes, sir.
I have a clarification question, which may be cultural. I'm not sure what you have in mind by the 2 words at best. And would you agree that we can say claims of backward compatibility applies to draft Ukraine?
Yes.
Thank you.
I'll agree to that because your draft does not add LSEs onto the label stack.
Yeah, I agree with you, but I would have liked that summary to be part of the summary you showed also. But it's fair to have it in the slide. Thank you for that.
Thank you, Bruno and Ketan.
Quick couple of clarifications. One is, does the MEAD proposal plan to cover entropy and all other special labels that are out there, or is it just entropy? And is that something that was been kind of agreed in the requirements that this is MEAD would be encompass everything?
Well, I can't speak to what all proposals are going to do. Of the proposals I have seen, there are opportunities for adding lots and lots of various things onto one SPL. And I am assuming that we're going to basically try to cram as much functionality into one SPL as we can.
Okay. Which of those 2 could you refer to that? Because I think I was able to see it only in one proposal, the JAG's draft that covered entropy. Maybe I missed the others.
And then Kariti's draft for FAI also carries entropy.
Okay. And a second clarifying question, or second and last. This is about MEAD, right? I wanted to know your views on the draft DECRAN and what it proposes. And do you see any problems with that?
So I have no problems with that.
Okay, thank you.
Okay, thank you, Ketan. Loa? Loa, go ahead.
need to write this up as a draft. And I would very much welcome a draft on this. It's so much easier to discuss in the working group if we have, or also in the design team, if we have a draft.
Since this appears to be controversial, I would be happy to write a draft.
Okay.
Okay.
Wim? Oh,
Yeah, Wim Hendricks, Nokia. Yeah, so I also wanted to clarify, but I think in the meantime it's done. I think most of the statements are not in the context of Bruno's draft, but actually on all the extension that has been proposed on top of that. But I wanted to
your
repeat what I
voice
said.
is very faint.
Is it
Your
faint?
voice is very faint. Can you
Repeat? Is this
come
better?
closer? Now it's a little bit better. Yeah, go ahead.
Okay, wait. Is this better?
Now it's
Yes.
much.
Okay, avoid the mask. What I was trying to say is also clarify that most of the claims are not in the context of Bruno, because where I'm coming from is the following, Tony, right? So we have, in my view, we have learned from the past, and I take the example of IPv4 and IPv6, which is maybe not the right context, but if we change too many things, it's going to take a long time before it's adopted. And I think you alluded to some of your claims in the presentation. And we have to probably segment the extensions that we want to do in MPLS in two phases, in my view, right? One is, what can we do with the minimum effort? And in any proposal, I do agree that we have to do microcode change, but we have to see with the legacy systems that we have, what type of extensions can we support using that legacy hardware, if you will, which in any form or anything that we are proposing will need to do an upgrade, right? So I'm not disputing any of that, but I believe we have to segment the, let's say, the implementations in two phases. One is what I call maybe a minimum set that allows us to have something fairly quickly, and fairly quickly means, and I don't disagree with you, three-ish years, maybe a little bit longer. But and then have maybe something on which is much more extensible, and look at what that would mean. And I would like us to segment the problem spaces in those two categories, because otherwise we might boil the ocean and takes us years before we get anything. And I gave the example uh, in the morning session about the entropy label. Just to give you an indication, I went back to the draft. The specification was 10 years ago that we have RFC, and I can tell you today there is still a bunch of networks that do not support it. Okay.
Well, there's no question that that's going to take some time for MEAD to get adopted and get out there. And there's no question that having all of the functions is going to take an arbitrarily long amount of time. The only question on the table really is, does reusing ELI save us time in getting deployed? And I don't see that it does anything towards that.
Yeah, my point, Tony, is for a minimum set of functionality, I think it does.
Okay.
Well, somebody needs to explain that, because I don't see that it matters one whit.
I think Bruno's draft does that, in my view.
Bruno's draft doesn't apply, because Bruno's draft is only talking about cases where we can just reuse ELI and not add additional LSCs onto it.
Correct. So
When
which
all of
gives
the
us
other
already a
proposals,
set of capabilities without doing the full.
Can we take it to the list when?
All right. Thank you.
We're running out of time. I do want. It's not a question, Tony. It's just a sharing a concern. We said ancillary data can change along the path of the packet. If we put ancillary data in the entropy label, then it will break hashing. Maybe you mentioned this or you touched upon it, but yeah, quickly. That's it. That's my comment.
Okay.
Kiriti, if you can make it very quick, please. We are
Yes.
eating into the
So
last.
first comment is that thank you, Tony, Stuart, and John, for this. I think it's very important. Second thing is I wish you had spoken up at the PALS joint meeting. And third is if we do this hack, and even Bruno's draft for me constitutes a hack, we're not making forward progress. We really want to make forward progress in MPLS. Thank you.
Okay. Thank you. And I will switch right away to the next set of slides. By you, I think it's extension headers. I'll try to give you the time that you asked for, but we will go over time. Go ahead, by you.
Yeah. Thank you. Yeah. So I have probably 5 minutes to cover this slides, and I will be on behalf of our co-authors to give an overview of a set of related drafts centered on the theme for MPLS extension headers to enable extensible in-network services in MPLS networks. Next slides can. Yeah, first a little bit history. We started this work in mid of 2018, and after that, it has evolved a lot. Today is already the version 06, and also later in 2019, we decided to split the document and spin off a part to discuss the options for the extension header indicator. And also, we have two other documents covering the architecture, network architecture of using extension headers and some other operational optimizations to make the header processing faster. So next slide. So the basic motivation for this work is that we have seen recently there are a lot of in-network services over user packets are introduced. These use cases include in-situ OEM, network slicing, service function chaining, multicast, segment routing, network programming. We can see some common requirements to these applications. First, we do need to encapsulate some actual instruction header or metadata in user packets. And also, these headers are needed to be added, removed, or processed totally within the network. And also, these applications are mostly orthogonal, which means multiple such applications may be stacked together and coexisted in a single packet. And also, since they are applied to user packets, they should support fast data plane processing. That's a requirement, a performance requirement we need to care about. And so now the issue is we should also consider to support these new applications in MPLS network. Therefore, we have this work. Next slide, please. Yeah, so solution is MPLS extension header, and we shall stop designing piecemeal and incompatible solutions which compete the same resource. We have seen several proposals just like this. They specify some new special purpose label, and they claim the location after the label stack to fit the actual header and metadata. But if you consider multiple such applications to be applied at the same time, there'll be issues about that. So we should have a generic framework once for all. So in this proposals, we have this extension headers. We will put this extension headers between the MPLS label, stack, and the payload, and with an in-stack indicator to tell you have this extension headers. So extension header is not new. It's already being used in IPv6, but there are some issues about IPv6 extension header. We should learn some lesson from that. The first that for IPv6, the extension header can only be added and removed by the end host. But here, clearly, we need to support in-network adding and removal. And also, in IPv6, there's only one hop-by-hop header is allowed. So which means if you have multiple HBH functions, you have to put all of them as options in a single HBH header. Therefore, you create a hierarchical structure. But for the simplicity, we should allow multiple HBH headers together to be chained. So we will have a flat structure for processing. And also for IPv6, we need to scan through all the extension header to reach the original layer 4 headers. It can be slow if the so here we should allow we can skip all the extension headers in just one step to access the layer 4 headers if needed. And in IPv6 is if you meet unknown extension headers, you will drop the packet. Here we should just ignore the unknown extension headers and still keep forwarding the packet. Just make sure for the compatibility issues. And also for IPv6 extension header is not necessary for fast path processing. But here we should optimize for data plane fast path processing. So next slide. Yeah, so I think the high-level requirement is the flexibility, extensibility, performance, and the backward compatibility. Maybe we can just go the next slides to quickly recap. Okay. So this slide summarize all the possible options for the indicator, in-stack indicator. You can see here we have a 4 group of possible solutions which cover all the possibilities, as I think in other talks discussed today. But there are some conclusions from the OpenDT. We will not go to the GAL GSH path. And also in this draft, we indicate that we prefer to use a single special purpose label as an indicator. Next slide. Maybe we just skip the details. Next slide. This is how we specify the special purpose label. And for the extension header.
Sorry, I just wanted to let you know if you can, summarize what you want to say. We are over time, but I promise to give you some time, and I think Meet Echo will not close the session.
Yeah. Okay. Then. Okay. Maybe just skip the slides.
We are on slide 8 right now.
8 extension header, right?
Yeah.
Yeah. So we could support multiple extension headers in one packet when we simply chain them together. And we also use a next header type to indicate the next extension header. We have several special next headers provisioned to support different cases. For example, none means there's no further extension headers. And unknown means this is the last extension header, and follow it is a payload, but what type of it we don't know. And MPLS means there's another MPLS label stack follows the current extension header. Also, we support edge-to-edge and hop-by-hop type of extension headers, and the hop-by-hop headers will be always put in front of the edge-to-edge headers for the purpose of performance. Next slide. Yeah, this is the details you can find in our draft on how we define the format of this extension headers. You can see they are basically, structurally is very similar to the IPv6 extension header, but with some extra information about that. Next slide. Maybe this more details about how to optimize operation. You can refer to our drafts for the details. Next slide. Yeah, so here's some hardware implementation consideration because we need to make sure it works in the fast path. Therefore, we should design for simplicity and performance. And we believe a simple post-stack extension header chain with a simple indicator, in-stack indicator, is a most simplest way which can minimize parser for final state machine and also the steps, which is good for both storage and the latency. And as I just said before, we put the HBH headers before the E2E headers, so to maximize the usability given the limited header buffer size. And also, we prefer to put the extension header indicator at the bottom stack for simplicity and backward compatibility. And we could use FEC labels to avoid unnecessary label stack scanning. I just skipped this slide, so you can read our drafts for more details. Next slide. So the summaries, we believe extension header is a generic solution for MPLS network services. It's built on a common industry practice and keep performance, flexibility, and extensibility in mind. It's also very compelling for MPLS network because MPLS label stack overhead is much smaller than IPv6, and it's protocol independent, can encapsulate various protocols. And also, we don't have too much history burden like IPv6. We have more freedom for innovations. Thank you. That's all my slides.
Okay, thank you. We don't have much time. Actually, we're over time, and I did close the queue. If any questions, please take it to the email list. And at this time, I will ask my co-chairs if there's anything else they want to share before we close this session. Loa, you want to speak? I see that you have the mic on. Loa?
I don't know if you can hear me.
Now I can. Now I can.
Okay. I think it's fine to close.
Okay. All right. Thank you so much for a very productive session. We'll see you next IETF or even the design team weekly meeting. Thanks a lot.
Thank you. Bye-bye.
Bye-bye.